Hi everyone, and welcome to the video clip. In this tutorial, we're going to be looking at task 1 of the Linux Basics Lab. So that means we're going to be doing exercise 8.8 in the Linux Fun PDF book that we can download from Econostoga. So I'm not going to just go through and tell you what the commands are. I'm going to put a bit of commentary around that. So hopefully that's going to provide a little bit more insight as to what the commands are that we're using and why we're using them. So let's get started. The very first step in this particular exercise is displaying what our current directory is. This is something that we do a lot. You end up buried down in some sort of a directory structure somewhere, and we know from the command prompt that the only thing we see from a directory perspective is the last directory in the entire path. So I'm already logged on to my Linux server. I'm actually using a secure shell connection for this rather than the console. And the reason I'm doing that is we have a lot more control over the fonts that we use and the size of the text. So this is something that's going to make it a little bit easier for you to see. So I'm going to start off with the first command in order to display our current directory. So that's going to be pwd or print working directory. We use this all the time in the Linux world. So I'll just go in and say pwd, I'll hit enter, and we'll see that the path is going to be /root. So that tells us that we're at the root directory from an absolute perspective right underneath the file system root or the root directory. So this /root is actually the home directory for the root user. Normally what we do is if somebody says the root directory, that means simply /. So we're at the very top of the directory tree under those circumstances. So that's the first command. We're going to be using this pretty continuously as we work our way through the exercise. Okay. Second step is we need to change to the etc or the etc directory, which is under the file system root. Now here we have a choice to make. We can either use an absolute path, so start with / and work our way down to etc, or we can use a relative path going from where we are right now, /root, over to wherever etc is. And one thing to remember when you're choosing a path is we're always looking to minimize keystrokes. So how do we figure out if it's going to be fewer keystrokes if we do an absolute path or if we do a relative path? Here's a pretty good rule of thumb to look at. Right now, I'm in a directory that's somewhere underneath the file system root. So I'm in /root. I need to go to /etc. And the first question we have to ask is, how far do I have to work my way up the directory tree until I find that common directory in order to get down to the target? And if I do have to go all the way back to the file system root or / to get there, normally it's going to be fewer keystrokes to use an absolute path. So that's what I'm going to do. So I'm going to do a number of different commands here with change directory or cd to change into a different directory. And the first thing I'm going to do is use an absolute path. So I'm going to say cd. And then in order to get to /etc, I just do / start at the file system root and then etc, and that will take me down into that directory. Notice now that the last part of the command prompt is etc, so that tells me that I'm in the etc directory. If I want to verify that, again, I can do pwd, and that's going to tell me that I'm in /etc. Great. So we've made our first command that we're going to do to change directories, and if you remember your command line work that you did in Windows, then this is going to look pretty similar to that. Right. So next step, in step 3, what we want to do is change back to our home directory, and we only want to use 3 keystrokes to get there. Now this is really easy to do because in the Linux world, if you do cd and hit enter without specifying any parameters on that command, it takes you to your home directory. This is one of the things that's a pretty big difference between Windows command and in Unix. If you remember in Windows command, if you want to know what directory you're in, you do cd and you just hit enter, and then that gives you the path. So that gives you the same output as what pwd does in the Unix world. I'm just going to hit enter here, so that would be my third keystroke. C is first, D is second, enter's third, and we can see that I'm now back in my home directory, which is being represented as the tilde command. So fairly easy from that perspective. Now, next thing we want to do, in step 4, we want to change to the grub directory, which is underneath the boot directory. Again, we can use relative or absolute path, But because we're going to go into a different directory structure from where we are right now, and that common denominator is the root or the slash, then I'm going to use absolute paths again. We could do this in 2 steps. We could change to the boot directory, and then we could change to the grub directory, but it's a lot better to do it as a single command. So we just specify the entire path when we're going to do that. So I'm going to say cd, and I'll just say slash boot, so that's to the first directory in the path, slash grub, which is the second directory in the path. Okay. Now, one of the specifications is that we were supposed to do this change with only 11 keystrokes. And if we count up how many keystrokes we used, it was actually more than 11. The reason that the exercise is asking you to do that is to start getting used to using tab completion. And we should be using this all the time when we possibly can, because again, it saves typing, and therefore we don't have to make as many mistakes by hitting the wrong key. So I'm just going to back up here a little bit. If I get to B and I hit tab, we can see that nothing happens. If I do tab twice, we can see the options we have. There's ambiguity. We can either go to bin or we can go to boot. So if I put an O, I know that I'm not going to have something unique. Okay, bin and boot are different, and those are the only 2 things that start with B. So if I hit a single tab at this point in time, that expands out and does the boot. So now I've done C, D, space, slash, B, O, tab. So I've done 7 characters so far. Now I just have to get into the grub directory. And what we're going to see is we don't need all 11. If I hit the G, that's my 8th character. And if I hit tab, that takes me out through entire grub. So I've only used 9 instead of 11 characters. So that's even quicker. Just hit enter. And again, we'll notice that we're in grub. That's our current directory. If I do pwd to see the entire path, then we can see it slash boot slash grub, which is exactly what it is that we wanted to do. All right. So that takes us through step 4. Okay. Now, step 5, we're going to do some more directory changing. But in this particular case, what we're going to do is move up to the parent directory. So we can see by the output of pwd that boot is going to be the parent directory of grub in the hierarchy. Now, in this case, if you're going to move to a parent, it's typically a lot quicker to use relative path, because the double dot directory entry is the one that's always going to take us to the parent directory. So in this case, all I have to do is say cd space and then ... Again, here's something that's a little bit different than what you find in Windows Command. In Windows Command, if you do not put the space between the cd and the ... it works. Something that was a bug ages ago and was never taken out because it was buried into so many scripts. But in Linux, there's no forgiveness for that. So we have to put the space in to make sure that we do not have a problem. Hit enter, and we can see that our current directory is now boot. If we look at the path, that should tell us that we are in slash boot, and sure enough, we are. So far, so good with that one. Okay. Next step, step 6. What we want to do is change to the root directory. So again, we've got 2 choices. Are we going to do relative path, or are we going to do absolute path? If we do relative path, we are 1 directory underneath the file system root, which means it would be cd and then ... to get up 1 level higher. If we do absolute path, it's going to be cd and then slash, which is only 1 character. So it's 1 character difference, not a whole lot. In this particular case, it really doesn't matter a whole lot. But at the same time, I'll go to absolutely the root directory. So slash with cd, and there we go. So we're now at the root. The only time you're ever going to see a slash in the path for your command prompt is when you're actually in the file system root. So that's kind of an introduction to changing directory and moving around within the directory structure. Next thing up, we have a number of commands that we're going to be going through to look at directory content. So step 7, the first thing we want to do is just take a listing of whatever contents is in the root directory. Because we're already in the root directory, all I have to do is type in ls. I don't have to specify any parameters, because by not specifying any parameters, it's going to give me a listing of the current directory. So I'll just put in ls, I'll hit enter, and we can see the content of the root directory. Just about everything in here is going to be directories. The only thing that's not, we see things like bin, lib64, sbin, lib, those types of things. Those are actually symbolic links or links that point to a different directory within the directory structure. The reason that we see that is with Red Hat 7, there have been some changes to the way that the directory structures are. It used to be that physically bin and then /user/bin were two different directories, and now they've basically been combined into one as far as the commands are concerned that are contained within those directories. So as a result of that, what we see is those symbolic links, or basically a pointer that goes to another directory. But the closest thing you could think about in the Windows world with that would be a shortcut. Not exactly the same, but not too far off either. So that takes care of step 7. Now in step 8, what we want to do is we want to have a long directory listing rather than a short directory listing. So we can see with the output here on the screen that we don't have anything other than the names of what the file system objects are. If I do ls and then -l, which gives me my long listing output, we're going to get a lot more information about those file system objects. So it's exactly the same objects that we saw before. We kind of talked about this in class already. Over on the left, that very first character is going to be what kind of file system object do we have. So you'll notice the ones that have kind of a redirect have an L, that's a symbolic link. Everything that has a D is going to be a directory, and those are the only types of file system objects we have in the root. So it's either going to be a symlink or a symbolic link, or it's going to be a directory. Okay, fairly straightforward. The other thing I'm going to point out at this time is we do have some aliases available that get set up by the system. If I type in alias as the command, it'll give me a list of what aliases are defined. And the ones that I'm really interested in have to do with directory listings. So notice that there's one partway down the list there that says LL, and that says what it's going to do is ls-l and then specify we want color output. LL is an alias that's defined in practically every Linux distribution there is, and it's a shortcut to doing ls space -l. So if I was to just do LL and hit enter, I'm going to get exactly the same output. I use that all the time. You should too. It's just something that's a little bit quicker. So that takes care of step 8. In step 9, what we want to do is look at the content of the etc directory, but we don't want to change directories. Again, this is something we do a lot. We're in some directory, we want to look at the content of some directory. We don't cd into it and then use the ls command. Instead, we use the ls command, and as a parameter, we specify the directory we want to do the listing to. So I'm just going to do ls, and then as the parameter, I'm going to say /etc. So that's the directory I want to provide the listing. And I hit enter, and we see all of the content that is in the etc directory. Again, we've got a number of directories in here. We have a number of files. We'll have some symlinks as well. Not going to worry about what types of objects they are right now. Right. So that takes care of step number 9. Okay. Now, the next thing we're going to do is we're going to list the content of bin and also sbin. And what we're trying to point out here is that we can have multiple parameters that we provide to commands that deal with the file system, and it will process both or however many parameters that you happen to have. So if I do ls and then /bin, what I'm going to see in there is all of the commands that are part of bin. If I do ls and then /sbin, I'm going to get a list of all the commands that are in the sbin directory. If I want to see both of those at the same time, I can say ls/bin space and then /sbin. So that says I'm going to do a listing of bin, and then right after that, I'm going to get the output of listing sbin, all in the same screen. So if I just hit enter, I get, this actually looks like the same as what it was before at the end. But if I was to scroll up in my output here from PuTTY, we can see that we've got a whole bunch of output that goes well beyond what we had before. I can see that, in fact, I'll go back down here a little bit. We can see where, if you look up at the top of the screen there, there's getting up into the higher part of the alphabet. So if I scroll up, I can see here we have all the A's, which are part of sbin. And then after that, what we see is the bin part, which is right above that. So you can see the break on the screen there where it says sbin, and then the output from listing the bin command is above that. So that's kind of the ability to operate on two different file system objects at the same time with a single command. And that we're doing with ls, but that works with all the other commands that manipulate file system objects too. So if we wanted to use, for example, the less command, the cat command to display files, if we wanted to use the copy command, we can specify multiple file system objects as the input type of a thing. So that takes care of step 10. Our next step, step 11, what we want to do is look at a directory listing of our home directory. So here, the nice thing, because we know that the tilde character is always going to point to home, we don't have to know exactly what the path to home is. So if I do ls and then I do tilde symbol and hit enter, I can see everything that is in my home directory. And there's not really much there at this point in time, or at least nothing that's visible anyway. Okay. And that brings us to the next part, which is in step 12, and that is, well, what if we have hidden files on the system? In the case of Linux, what ends up happening is if you want to hide a file, there's no attribute like we have in the Windows world. What happens instead is if you start the file name with a period, then it's hidden. And looking at the output of that previous command, when we just said ls and tilde, it looks like I've only got one file in my home directory. But there's actually some other stuff in there. So what I'm going to do is I'm going to say ls, and then the example they use in the book is al. So we're going to do a long listing, and we're going to show everything that is in there. So a is all. And then I have to specify what directory. So I'm just going to do the tilde again, which is going to point at my home directory. Now if I hit enter, we're going to see something a little bit different here, because we've still got Anaconda config file, which is still there. But look, if underneath that, and you see a whole bunch of entries that start with a dot. So there's bash history, bash logo, bash profile, bash rc, that type of a thing. So those files are all in our directory, and they are hidden because they start with the period. The other thing I want you to notice about the output of this command, because I want to show you something a wee bit different, is that the very first entries are dot and double dot. So again, just like in file systems you're used to with Windows, there is a directory entry which is dot, which points to itself, and then there's a double dot that points to the parent. That's how when we do cd dot dot, it knows where to go. Okay, that's great. Now what if we want to get the output, but we don't want the dot and the double dot part? In other words, we're not interested in the pointer to itself, the self-reference, and we're not interested in the parent. What we can do with that is we can do ls, and then we do capital A instead of lowercase a and L, so again, long. And again, I'll point at my home directory, and we're going to see the change in the output here. The dot and the double dot are going to be missing. Okay? And we can see that in the output once the command executes. Now, where this comes in handy, when you're looking at things on the screen, it really doesn't make a whole lot of difference. But a lot of times you might be creating a script and you want to generate the output from the ls command, but you don't want the reference to the directory that you're in, nor do you want the reference to the parent. So pretty useful from that perspective, and that's generally where we're going to use that. Okay. So that's the ls al with both the uppercase and the lowercase a. The other thing I want to point out, one other thing, we said before we have this alias called ll. Okay, that's great. And what I'm going to do here is I'm going to do ll, and then I'm going to also add in the a option, which we can absolutely do. So there's nothing that says I can't use an alias that has an option on the command and then add more options after the fact. So if I do ll and then -a, I'm going to get that long listing without actually putting in the L option the second time. So, oops, sorry about that. Let me go back and point at my home directory. I forgot that part. But there we see it with the LL. So that says from the alias perspective, long listing, and then A, which is going to give us the hidden content. Okay. So that kind of takes care of step 12. Okay. Now, step 13. Next thing we're going to do here is going to do a listing of what's in the boot directory. But we're being asked to put this in human readable form. And basically all that does is by putting the H option on this command, we're going to be able to see the size of the files in something that's a little bit more easy to read for humans than the computer. So let me first do a listing of the boot directory. I'll do a long listing, and I'll just do /boot. easiest thing to type from where we are. And I'm going to put the output, but I'm not going to do the human readable part. So when I hit enter, we can see that there's a number of files. And when you look at the size right next to that second root word that's in there for the group ownership, some of those files are pretty small. Some of them are fairly big, but the output is all in bytes. So it's pretty hard. If you look at something, for example, even that very top file, that config file, 126.426. So that's, in around the 120 kbyte size type of a thing. But you have to start counting over the characters in order to figure out what's kilo, what's mega, what's giga, all the rest of that kind of thing. So if I change this up and I say, I'm going to up arrow this, so I'm going to do the same command, but I'm going to come back over here and I'm going to insert -L into, -H into the command. So that's going to change the output of the size of the files and give that to me in something that's a little bit easier for humans. So I'll hit enter. And now notice the output. So, that top file, 124 kbytes. If we look at things like the kernel, that's 5 megabytes. Much, much easier for humans to read. And in fact, what I do as a personal preference, if I'm setting up a Linux system I'm going to be working on a lot, I create my own alias, even for things like LL. I change what the system does, and I automatically put -H in there. So whenever I'm doing a long listing and looking at size, I see something that I can very quickly read and figure out how big the file system object is. Okay, so that's step 13, and that's looking at human readable output. So we've now done a number of different commands that allow us to list what's in directories. The last thing we're going to be looking at here is directory manipulation. So in step 14, what we're going to do is create a directory called tester, and that is going to be in our home directory. Now, right now, we're not in our home directory, so that means that I can specify an entire path without having to cd into the directory. And again, that's something we do a lot, and it's something you should get used to. There's nothing wrong with changing into a directory if you're going to be creating a whole bunch of files and directories there, and that saves you a lot of path typing. But if I'm in some directory and all I want to do is create one directory someplace else, I don't want to have to cd to it, create the directory, and cd back to where I was again. Especially if where I'm starting from is quite a long path. So, having said all that, let's create the directory. Creating a directory is makedir. There's no shortcut like MD like you have in the Windows side of things. So I'm just going to say makedir, space, and then what's the path? So I'm going to say tilde. It's going to be on my home directory, and underneath that, I'm going to continue the path with a slash, and this is going to be tester. Hit enter. It creates the directory. If I do a listing of what's in tilde, then here we can see that tester directory. It's the very last item in the list there. Perfect. That's exactly what we want to see. Couldn't be much easier to create a directory. Okay. Now, what we're going to do is change to the etc directory. And again, this is just to give us some practice working by creating directories from a different directory. So fair enough. I'm going to cd into etc. In the book, what they've done is they put a semicolon on the end of this and put the other command behind it. I'm not going to do that. You can do if you want. All that semicolon says is execute command and then do another command, and I'm going to type it all in one line without hitting enter. But I don't want to do that from a demo perspective. So I'm going to hit enter. Notice in the command prompt now that it's etc on the end. If I do pwd, I can see that I'm in the etc directory. Okay. So the next part of that is creating this directory called newdir in my home directory. So I'm going to simply do the same as I did before. I'm going to say makedir. I'm going to do tilde to say that that's my starting point in the path to create the new directory. And since newdir is going to be underneath my home directory, I just do slash to say let's continue the path, and newdir and enter. If I now go back and do a long listing of my home directory, we should see that new directory called newdir, and sure enough, there it is. Perfect. So we've got our two directories created. In both cases, we were not in the directory that we were creating our new directory in, so we have to specify the path somehow to get to wherever our home directory is. In this case, because that's the target, we simply use a tilde. If it wasn't our home directory, again, we would have to make a choice. Do we do a relative path and work our way up or down, whatever that happens to be? Or do we do an absolute path and put slash at the beginning, which means we're going to start from the file system root. Fairly straightforward and simple from that answer, or perspective. Right. Now, step 16, step 17. I'm not going to bother doing 18. I'm going to pretend that I don't have enough time. And it's something we don't really do very often anyway. But step 16, what we're going to do is create something called dir3 in our home directory. Now, dir3, though, is underneath another directory called dir2, which is underneath another directory called dir1. So basically, we've got from our home directory, we have dir1, then dir2, and then dir3. So what happens if we come along and say I want to do make dir? It's pretty simple, right? I'm going to say, okay, start at tilde slash dir1 slash dir2 slash dir3. Piece of cake. There's my path. Start at the home directory and then stack those three directories on top of each other. I'll hit enter, and in this particular case, I get an error. Now, why am I getting an error? Basically, what this is saying is it can't create the directory dir3. And the reason for that is if you're trying to create a directory underneath a directory that does not exist, in other words, the parent does not exist, it's not going to be able to do that. So it's not just going to go by default and start creating all kinds of directories for you. Okay, that's fair enough. Now, to get around that, though, we don't have to go through and create all those directories individually. One of the things, and we use this a lot in the make dir command, is the P option. And basically, P says create the parent directories on the fly if they don't exist. Okay, let's try that out. What I'm going to do is I'm just going to up arrow, so I'm going to repeat this particular command, but I'm going to arrow over here in front of my parameter, which says what am I going to try and create, what directory I'm going to create. I'm going to say -P, I'll hit space in there. So that says create all the parent directories, so create the entire structure on the fly. So if I say enter, we don't have any errors, that's great. If I do a long listing of my home directory, then I can see here's this new thing called dir1. Okay, great. Well, what's inside dir1? If I do a long listing of tilde slash and then dir1, I can see there is dir2. That's what's the content of dir1. And if I say I want to look at the content of dir2 underneath dir1, then I can see that there's dir3. So we created all of those directories in one fell swoop with a single command, very, very simply. Just a path to the final directory, the one that's the lowest in the hierarchy. And we use the P option, which says create everything we need to above that in order to get that directory created. Again, something we use all the time when we're working with Linux. Okay. Last thing we're going to do, step 17, is to get rid of testdir. So again, if we look in the output that we see on the screen, there's a directory called testdir, which is in our home directory. The command that we're going to use for that is remove directory rmdir. So creating a directory is mk or make dir, and getting rid of a directory is rmdir or remove directory. So all I have to do for this is rmdir space and then the path. So tilde slash testdir. And again, I'm getting used to doing this tab completion. So I did TE and hit a tab, and I got testdir. Awesome. Now, the one thing I do want to point out with remove directory is the only time this works is if the directory is empty. If there was content of any type inside testdir, files, other directories, doesn't matter what they are, then this command would not work. We're going to look at that in another exercise, but for now, rmdir is going to work fine. All I have to do is hit enter. No errors. I'll do a long listing of my home directory, and sure enough, testdir is now gone. And one last thing I want to point out at the completion of this exercise, I've been executing all these commands for creating directories, removing directories, all the rest of that kind of thing. I'm still in Etsy. I've never left there. So I don't have to change into my home directory to be creating and deleting directories and things like that, or whatever else I might want to do, copying, renaming, what have you. I can work from any directory that I want. And again, although it might be a little bit quicker with the different commands that we were doing here because everything was in the home directory, it might be a little bit quicker if we changed to that directory, but it's much better practice to be using the entire path so that if you're in some other directory, you don't have to change the directory, do what you're doing, and then change back, because all you needed to do is create some directory somewhere where you weren't currently. Okay. So that's a wrap on this particular exercise. Hopefully this was helpful for you, and the explanation will make things a little bit clearer what you were doing, and we'll see you next time.